Welcome to another physics class. In our last lesson, we started the topic simple harmonic motion. And when we concluded on that day, I promised today that we are going to look at work example based on what we have done on this topic. And before I continue, please, if I just joined us on this channel, please don't forget to like, share, and subscribe so that when I upload a new video like this, you'll be able to get the notification. So before we continue, let me remind you part of what we have done on that day. Note: 1. We said frequency of simple harmonic motion, frequency F is equal to number of revolution over time taken. 2. At the same time, the same frequency is equal to 1 over t. 3, where t, the capital T, is period. And from what I've written on the board, t also will be 1 over f. 4. Our t also, which is period, can also be, from what is on the board, can also be t over n. 4. 5 will be equal to angular speed of velocity. Omega is equal to theta over t. Now, for complete cycle of vibration, or you call it oscillation. For complete cycle of vibration of oscillation, then we are going to have our theta is equal to 2 pi rad, and our small t will be equal to capital T, that is total time taken. Total time taken. That is, according to the profile I show on that day, for complete oscillation, we are going to have something like this. This is for complete oscillation. Here is pi over 2 rad. Here is pi rad. Then at this particular point, we have 3 over 2 pi rad, and here we are going to have 2 pi rad. And mind you, as I told you on that day, 2 pi rad is equivalent to 360 degrees. Don't forget, we've done all this one. Now, if that is the case, we can now have this one as number 6, that omega will be equal to 2 pi over capital T. That is for complete oscillation. Since we said, remember, we said, but T is equal to 1 over F. Therefore, from this one, we can now have omega be equal to 2 pi over 1 over F. So we are going to have 2 pi divided by 1 over F. So we are going to have 2 omega will be equal to 2 pi multiplied by f. So finally, we are going to have number 7 as omega is equal to 2 pi f. Also, from 6, if we cross multiply, we are going to have t omega is equal to 2 pi. Therefore, the period t, period of simple harmonic motion, t can also be equal to 2 pi over omega. Also, let's take this one as number 8. We talk about velocity of SHM. That is, V is equal to plus or minus omega square root of a square minus s square. Don't forget, we've done all this one. This is just to remind us before we move to the work example. And we said to have maximum velocity, where s will be equal to 0. So maximum velocity will occur that is at the middle of the oscillation. At the middle of oscillation. So if s is equal to 0, we are going to have maximum velocity, V maximum, as plus or minus square omega square root of a. Then we are going to have V maximum equal to omega a. So take this one as number 9. We talk about displacement of SHM as x when you displace it from equilibrium position. And we say x, which is displacement, will be equal to a sine theta, where our theta is omega t, where theta is equal to omega t. Therefore, the displacement of simple harmonic is equal to a sine omega t. Last one, which is number 10. Number 10 is acceleration of SHM. And we said by then, acceleration of SHM, A, will be equal to minus omega square A, minus omega square S. Don't forget, S is displacement, where A there is amplitude. Now, since our S is A sine omega t, then we are going to have the acceleration of simple harmonic motion as minus omega square A sine omega t. Don't forget our omega t is the angular distance or angle turn. So from there, we said we are going to have maximum velocity. A maximum will occur when x is equal to a, that is at the extreme or end point of oscillation. So A maximum, therefore, our A maximum can now be A maximum can now be minus omega square S or minus omega square A, depending on the question. And don't forget, the minus here indicates that the acceleration is directed toward the fixed point or toward the equilibrium position. So we come across all these formula during our last lesson, which we promised that we are going to apply each to solve problem today. Now, let's take this one as example 1. A particle undergoes simple harmonic motion with an amplitude of 5 centimeters and angular velocity of 12 pi rad per second. Calculate 1. A. Maximum velocity. B. Velocity when it is 2 centimeters from equilibrium position. And C. Maximum acceleration of the particle. D. Period of oscillation. Now, let's solve this one. Solution. The first thing, let's write out the parameter there. Here now, A is given. Amplitude. Amplitude A is given as 5 centimeters. But look at velocity. Velocity is given as 12 pi rad per second. That's the correct unit. So we need to convert this one to meter. So that is the 5 divided by 100. This one will now give us 0.05 meter. So velocity, angular velocity is given. Angular velocity, that is omega, is given as 12 pi rad per second. Then equilibrium position, from equilibrium position, according to question B, displacement also is given. Displacement X is given as 2 centimeters. Because of this one, again, let's convert it to meter. That one will now give us 2 divided by 100. That one is 0.02 meter. Now, the first question says to calculate maximum velocity. Now, to calculate maximum velocity, let's look at what we have for maximum velocity on the board. That is, we are going to have maximum velocity when s is equal to 0. So we are going to apply this formula, this particular formula. So if that is the case, we can now say that 1. Maximum velocity V will be equal to omega A. And our omega is given as 2 pi rad. This one will now give us 12 pi rad per second multiplied by 0.05. For maximum velocity equal to 0.6 meter per second. That's maximum velocity. Now, because the value of pi is not given, so we need to calculate in terms of pi. That is 0.6 pi meter per second. Let's take B part of the question. This is A. Now B, velocity when it is 2 centimeters from equilibrium. So according to what we have on the board, we are going to apply this formula, because now both the displacement and amplitude is given. So we are going to have V is equal to plus or minus omega square root of a squared minus s squared. So this one will now give us plus or minus. Our omega is already given according to the question. That is angular, that will be 12 pi into square root of 0.05 square, then minus 0.02 square. Now, this one will now give us plus or minus 12 pi into square root of 2.5 times 10 raised to power minus 3 minus 0.4 times 10 raised to power minus 3. And this one will now give us plus or minus 12 pi into square root of 2.1 times 10 raised to power minus 3. And 2.1 times 10 raised to power minus 3, the square root will now give us plus or minus 12 pi is 0.045. Now multiply 12 pi multiplied by 0.045. Now phi will be equal to 0.54 pi meter per second. 0.54 meter per second. That is the value of velocity when it moves 2 centimeters from equilibrium position. Now, question C now, which is maximum velocity and maximum acceleration. And don't forget, from what I've written on the board the other time, our A maximum will be equal to omega square A. That's the value of the magnitude of maximum acceleration. Now, if that is the case, mind you, our A is given on the board, which is 5 centimeter or 0.05 meter. So then omega is given. So we are going to have 12 multiplied by 12 pi square multiplied by 0.05. So when we square this one will now give us 144 pi square multiplied by 0.05. And the answer will be, now the final answer for this one will be 7.2 pi square. And this is acceleration. It will give us meter per second square. That is for question C under A. And the last one under A, which is D, we have to calculate period. And don't forget, I said our period, which is capital T, period, this is capital T, according to the formula written the other time, it is equal to 2 pi over omega. 2 pi over omega. And the value of omega, which is angular velocity given in the question, is 12 pi. So pi will cancel pi, so we have 1 over 6. And the answer will be, 0.1666 approximately. Capital T will equal to 0.167 seconds. Let's take this one as example 2. A body in SHM with a frequency of 50 Hz and an amplitude of 4 centimeters. Calculate the A period, B, acceleration at the middle, and at the end of the path of oscillation. C, velocities at the middle and at the end of the path of oscillation. D, velocity and acceleration at the distance of 2 centimeters from the equilibrium position. Now let's write out the parameter first. Now, according to the question, frequency F is given as 50 Hertz. Amplitude also is given. A, amplitude is given as, that is A, 4 centimeter. Convert to meter, that is 4 over 100 equal to 0.04 meter. And if you look at question D, we are given displacement there. So displacement X is given as 2 centimeter. Convert to meter, that will be 2 over 100. That one is 0.02 meter. So these are the parameters given in the question. So the fourth question says we should calculate period. That is A, period T. That says, don't forget, one of our formula is 1 over F. So this one will now give us 1 over 50. And the answer will be 0.02 seconds. That's the period of oscillation. Then B, part of the question, asks us to calculate the acceleration at the middle and at the end part of the oscillation. Note, A, acceleration is equal to minus omega square, according to the question, x. And from this one now, let's call this one B1, acceleration at the middle, B1, A at the middle. Don't forget, acceleration at the middle, then our theory says x must be equal to 0. If x is equal to 0, then we have A at the middle will be equal to omega square multiplied by 0, which is equal to 0 meter per second square. B2, A at the end of the end part of the oscillation, end part of oscillation, end part of oscillation. Mind you, and we said at this particular point, x will be equal to A. If that is taken and A is given, then which will be equal to 0.04 meter. So we can now say that the acceleration at the end part of the oscillation is equal to A equal minus omega square A. This one will now give us, don't forget, but our omega is equal to 2 pi f from what we have done so far. So we are going to have minus 2 pi f all into square multiplied by 0.04. So this one will now give us 4 pi square. Our f is calculated. Is given. That is multiplied by 50 square, or rather, let's do it together. 2 minus 2 multiplied by pi multiplied by 50 all into square multiplied by 0.04. Now, this one will now give us 10,000 pi square multiplied by 0.04. Since this one is 10,000, that is 2 multiplied by 100 square. That is 10,000 pi square multiplied by 0.04, and the answer is 400 pi square meter per second square. That is the acceleration at the end part of the oscillation. The next is velocity at the middle and the end part. So velocity of SHM V is equal to, as we said, plus or minus omega square root of a square minus s square. Now, 1. V at the middle, in that case, don't forget what we have said under theory. At the middle, x must be equal to 0. That is what we've done here. Now, if x is equal to 0, then we are now left with our v now, without wasting time, will be equal to omega a. Then, from there, we can now say our v will be equal to 2 pi f a. So this one will now give us 2 multiplied by pi multiplied by 50 multiplied by 0.04. And this one will now give us, that is 2 multiplied by 50, that's 100. 100 multiplied by 0.04. Now, this one will now give us 4 pi meter per second. 4 pi meter per second, that is, it will be 100 multiplied by 0, 100 pi multiplied by 0.04. So the answer will give us 4 pi meter per second. That is the velocity at the middle. Then C2, V at the end part of the oscillation. Don't forget again, at the end part of the oscillation, we said A must be equal to S. And if A is equal to S and both is equal to 0.04, put it in this formula. So put 0.04 minus 0.04, that will be 0. So the V at the end part will be equal to, let me write it, plus or minus omega, that will be 0.04 minus 0.04, all into square. The whole of this one will give us 0. So the value for V at the extreme point will be equal to 0 meter per second, because this one will give us 0. The D part of the question, D, velocity and acceleration at a distance 2 centimeters from the equilibrium position. Here now, the value of A and S will be used together, that is amplitude and displacement. So the amplitude here is 0.04. According to the question, the displacement here is 0.02. So the velocity now, the first one, D1, velocity, according to the formula, will be equal to plus or minus omega square root of A square minus S square. So from here now, since our A is 0.04, S is 0.02. So we are going to have V will be equal to plus or minus 2 pi multiplied by 50 into square root of 0.04 square minus 0.02 square. Now give us 0.16 minus 0.04. So and it now gives us plus or minus 100 pi into square root of 0.12. So it will give us plus or minus 100 pi multiplied by 0.346. V now will be equal to plus or minus 34.6 meter per second. That is when the displacement is 2 centimeters from equilibrium position. Now to calculate the acceleration. So A will be equal to minus omega square s. And from the question, our s is equal to 0.02 meter. So we are going to have our A as minus 2 pi f all into square multiplied by 0.02. So according to the question, this one will be 2 pi multiplied by 50 all into square multiplied by 0.02. So this one will now give us 100 pi square multiplied by 0.02. And this one will now give us, A will give us 2 pi square meter per second square. The question we've answered from A to D now. And the final answer for this one is A will be equal to 2 pi square meter per second square. Let's take this one as example 3. A particle vibrates with simple harmonic boson such that the maximum displacement from the equilibrium position is 10 centimeters. If the acceleration is A equal to minus 9x, where x is displacement, calculate the angular velocity, B maximum velocity, and C maximum acceleration. Now to solve this one, let's write out the parameter given in the question. Displacement s is given. Displacement s is given as 10 centimeters. Then acceleration A is given as minus 9x. So the first question says we should calculate angular velocity. A now, angular velocity. And the symbol is omega. If that is the case, for acceleration, we have A is equal to minus omega x compared with the one given indicator, that is A is equal to minus 9s. It means A will be equal to minus omega square s, and A will be equal to minus 9s. So if you call this one equation 1 and this one equation 2, then this is A, this is A. We are going to have minus A omega square s is equal to 9s. S will cancel s. You have minus 9s. Then a minus will cancel minus. So we have omega square is equal to 9. So omega is equal to square root of 9, where omega will be equal to 3 rad per second. That's the value of omega. The second question says to calculate maximum acceleration, maximum velocity. That's part B question, maximum velocity. That is V maximum, and it will be equal to omega A. And for us to have maximum velocity, don't forget we said x must be equal to A. So if that is the case, then we are going to have V equal to omega x. And x is the question is given as 10 centimeter. X is given as 10 centimeter, that is displacement. So, but S is equal to 10 centimeter, convert it to meter, that is divided by 100. So this one will now give us 0.1 meter. So if that is the case, V maximum will be equal to the value of 3 multiplied by 0.1. So this one will give us 0.3 meter per second. See part of the question, maximum acceleration. Maximum acceleration. Maximum acceleration. So that one will now give us A will be equal to minus omega square x. And x is given in the question. So we are going to have minus 3 square into multiplied by our x is 0.1. It is given as 10. We've converted to meter. That will be 0.1. So this one will now give us 9 multiplied by 0.1. And this one, A will give us 0.9 meter per second square. That's the solution to this one. Take this one as example 4. The displacement of a particle vibrating with OF.SHM is given by S is equal to 20 sine 100 pi t. Calculate the A, amplitude of oscillation, B, angular velocity, C, velocity at t is equal to 0 seconds, D, maximum velocity and maximum acceleration. Now, from this question now, solution. Displacement S is given as 20 sine 100 pi t. Now, to calculate amplitude, don't forget the formula for displacement is equal to A sine omega t. And by comparing these two equations now, compare. If you compare the two equations now to calculate the amplitude now, A 20 sine omega t, A sine omega t, it means from here now, A is amplitude, which is equal to 20 meter. The second question says we should calculate angular velocity, that is omega. B, angular velocity. Use the same two equations. Take this one and this one. So it means our omega t will be equal to 100 pi t. So here now, t will cancel t. So we have omega will be equal to 100 pi rad per second. That's the value of angular velocity. The Third question says to calculate velocity at t is equal to 0. Velocity at t equals 0 seconds. Now, if you can still remember, in our last lesson, when an object is moving under circular motion, under simple harmonic motion, the velocity we have two components, the Vs component and the Vy. And therefore, the Vs, as we said in our last lesson, is equal to omega A cos theta. And from this question now, our theta is equal to omega t. Don't forget. So our Vs will be equal to omega A cos omega t. Now, the question says t is equal to 0. T equals 0. So we are going to have Vs is equal to omega A. This one will be equal to 0, cos is 0. And cos 0 is 1. So we have omega A. So therefore, our omega here is 100 pi. And our weight A has been calculated, multiplied by 20. So V, when at t is equal to 0, equal to 2000 pi meter per second. V now, V divided into 2, 1 maximum velocity. For V to be maximum, V maximum, that will be omega A, as we said in our last example. And if that one is omega A, so for V to be maximum also, since we have calculated it on the board, so we are going to have, that will be 100 pi multiplied by 20. So the same thing with the horizontal component velocity, that's 2000 pi meter per second. Then part B, maximum acceleration. Maximum acceleration, that is A maximum, that will be equal to minus omega square A. For us to have maximum acceleration, don't forget we said A must be equal to S. So therefore we are going to have, and since our omega is 100 pi, then multiplied by 20. So this one will now give us, that will be 10,000 pi square multiplied by 20. So this one will now give us 200,000 pi square meter per second square. So this one will now give us 2.0 times 10 raised to power 5 pi square meter per second square. That is A maximum. And that's solution to this example 4. Now let's take this one as example 5. A particle undergoes simple harmonic motion as its displacement given by s is equal to 0.12 sine 4 pi t. Calculate the A, amplitude, B, angular velocity, C, period of oscillation, D, frequency of oscillation. Now, solution. from the question, displacement also is given. S as 0.12 sine 4 pi t. Now we have to calculate amplitude. Now, as I said in our last example, our x normally is a sine omega t. So compare the two equations. Compare. When you compare the two equations, then we are going to have the first question, A, amplitude, will be equal to A equal to 0.12 meter. Second question, B, to calculate angular velocity, that is, compare this one with this one, that is, omega t will be equal to 4 pi t. So t will cancel t, so we have omega will be equal to 4 pi rad per second. That is omega, which is angular velocity. Question C now. C asks us to calculate the period of oscillation, and don't forget one of the formula for period, which is capital T, is equal to 2 pi over omega. And from here, our omega is 4 pi. So we can now say the period T is equal to 2 pi over 4 pi. Pi will cancel pi, so we have T is equal to 2 over 4, which is equal to 1 over 2, and our T now is equal to 0.5 seconds. So once you know our T, now it is now possible to move to question D. D asks us to calculate frequency, which is F. And from one of our formula, F is 1 over capital T. So therefore, that will be 1 over 0.5. So our F now will be equal to, our frequency equal to 2 Hertz. And that's the solution to example 5. For today, this is the convenient point to stop on the work example on the aspect we've done under simple harmonic motion. And don't forget, as I said earlier, if you are just joining us or you are with us before on this channel, you should not subscribe, please try to do so. Try to like, share, and subscribe so that when I upload a new video like this, you'll be able to get the notification. And in our next lesson, the topic simple harmonic motion still continue. We are going to move to the next aspect under simple harmonic motion. Thank you.